Hey everyone, welcome back to The Explainer. Today, we're actually diving into a lesson from the Foundry by Forge College. In our last module, we really nailed down designing and authoring deployment scripts. Today, though, we are moving from building the club to hiring the security staff. We're talking about scripting role management flows. Basically, think of your smart contract as an exclusive high-end nightclub. And today, we're writing the Node.js script for the ultimate VIP bouncer. Getting this right is absolutely crucial for keeping the riffraff out of your protocol, so let's just dive right into it.
Okay, here's our blueprint for today. We're going to hit 1, the access control bridge, 2, the setup checklist, 3, granting VIP access, 4, revoking the privileges, 5, debugging common mistakes, and lastly, 6, validating the blueprint.
All right, section 1, the access control bridge.
Now, you might be wondering, why do we even need these scripts in the first place, right? Like, why can't we just trust the contract code we already wrote? Well, think of your static smart contract code as the physical, immovable doors of a club. It's compiled logic. It doesn't move. Observable Node.js scripts, on the other hand, are your dynamic testing environment. They're literally the bouncer standing at that door actively checking IDs. These scripts are the crucial bridge between your hard-coded contract logic and real-world operational checks. They let us actually observe the state of our contract and, this is the big one, catch catastrophic security flaws way before we deploy it to a live high-stakes system.
Moving right along to section 2, the setup checklist.
So let's look at our engineer's checklist here to get our bouncer ready for their shift. First up, we connect. We instantiate our local RPC provider, which remember is basically our pipeline to the blockchain, and an admin signer. Now this signer is the club manager. They're the only one with the actual authority to hand out VIP access. Next step, we grant the role. The expected state here, our hasRole check returns true. Pretty straightforward. After that, we verify access by calling a restricted function, which should, of course, succeed. Then comes the fun part, revoking the role, ensuring hasRole flips back to false. And finally, the post check, which is basically making sure the restricted function reverts. This right here is the exact lifecycle we're going to script.
Okay, on to section 3, granting VIP access. It is time to let someone pass the velvet rope. And here is our core tool for doing that, grantRole. This is a programmatic contract function used to assign a specific role identifier to a target address. Just imagine the club manager taking a bright orange VIP keycard and handing it directly to a guest. That guest's address is now officially on the VIP list, boom, giving them access to the restricted areas of our smart contract.
So how does this actually translate into our Node.js script logic? Well, first, we call grantRole. And, this is key, we deliberately await the transaction receipt. This is absolutely vital. We literally have to wait for the ink to dry on the blockchain because, block times mean it doesn't just happen instantly. Once it's confirmed, we print the transaction hash for our logs. Next, we call the hasRole check just to verify that the membership actually changed. And finally, we throw an error if it returns false. Honestly, always assert your permissions before moving on. Always.
All right, section 4, revoking the privileges.
Because, let's be real, a true security test isn't just letting people in, it's seeing if our bouncer can actually kick them out when the party's over. Enter revokeRole. This safely removes role membership, ensuring subsequent restricted function calls are completely denied by the contract. It's the safe, observable, and honestly very strict removal of access rights. The VIP card is officially confiscated.
Here's what that crucial revocation workflow looks like. The admin calls revokeRole, and once again, we await that transaction confirmation. We then check that hasRole now returns false, but the real security validation happens next. We verify that calling the restricted function actually reverts. We are actively testing the bouncer here by having that user try to sneak back into the VIP area, fully expecting the contract to block them. No way in. Which brings us to section 5, debugging common mistakes. Because what happens when the bouncer inevitably gets confused? I want you to ask yourself, what if the network is actually lagging? Like, what happens if we check the ID before the manager's list has formally updated on the blockchain? Well, you get a race condition. You're reading stale state, and boom, your script fails.
In fact, there are 4 common script killers you're going to encounter. Number 1, the wrong signer. You're trying to grant a role, but you completely forgot to connect the account that actually has admin rights. Number 2, race conditions, like we just talked about. You forgot to await your transaction receipt. Number 3 is mismatched role identifiers, maybe a tiny typo in your string before hashing it. And number 4, ABI or address mismatches, meaning the translation manual between your script and the contract is totally flawed. Mastering these edge cases and handling them proactively, that's exactly what you practice in the advanced learning programs and community courses at Forge College. It is literally what separates a fragile script from a robust, production-ready one.
And finally, Section 6, validating the blueprint.
How do we prove all of this worked without human intervention? Look at this golden rule here. Always assert permissions before attempting changes. See, when our script finishes, we don't just want some messy terminal output. No, we want a machine-parseable JSON summary. This summary actually proves our granted, verified, and revoked states all hit their exact marks. It makes our script not just a manual operator tool, but a lightweight integration test, perfectly ready for an automated CI pipeline. That means it can test itself automatically every single time you update your code. If your JSON output's true for granted and false for revoked, you know for sure your permission model is solid.
So there you have it. You've hired the bouncer, you've tested the velvet rope, and you've verified the eviction process. You are totally ready to take this role management script right into the next capstone lesson where we test inter-module access boundaries. If you want to continue learning and explore way more incredible Web3-related topics, definitely visit forge.college. Keep experimenting, keep asserting those permissions, and I will see you all in the next explainer.